All the participants are kindly requested to turn off their video. So you can start now.
A very good morning, all of you. I, Professor Praveen Agarwal, on behalf of Anand International College of Engineering, welcome all the participants in the 5-day faculty development program on Python 3.4.3. This program is organized in association with IIT Bombay on remote learning through spoken tutorial project. Dear friends, my institute is well known for the technical education from since 10 years. It is our 11th year, and in short of a span of time, my institute is reached milestone in the field of the technical education. Now, this faculty development program on Python is organized due to the importance of the Python. Python is a general purpose and high-level programming language. There are many benefits of learning Python, especially as your first language we will discuss. It is a language that is remarkably easy to learn, and it can be used as a stepping stone into other programming language and frameworks. If you all are absolute beginner, then this is your first time working with any type of coding language. That's something you are definitely want. In these days, Python is widely used, including by a number of big companies like Google, Yahoo, Nokia, IBM, and many more. It is one of the beautiful learning and coding language due to its easy mode of learning. So I hope during this coming 5 days, you all are benefited from the faculty development program. I wish you my all the good wishes and all the best. Enjoy this 5-day faculty development program. Thank you.
Thank you, Professor Praveen Agarwal. All the participants kindly listen. Now we are going to start the videos. There are total 11 videos for the session, and each video will be played after a break of 1 minute. So just we are getting started the videos. Kindly be in the session.
Hello friends, welcome to the tutorial on getting started with Ipython. At the end of this tutorial, you will be able to invoke the Ipython interpreter, quit the Ipython interpreter, navigate the Ipython session history, use tab completion within Ipython, look up documentation in Ipython, interrupt incomplete or incorrect commands. To record this tutorial, I am using Ubuntu Linux 14.04 operating system, Python 3.5.2, Ipython 5.1.0. What is Ipython? Ipython is an enhanced interactive Python interpreter. It provides features like tab completion and easier access to help. Let us first see how to start the Ipython interpreter. First, open the terminal by pressing Ctrl-Alt-T keys simultaneously on the keyboard. Type Ipython 3 at the prompt and press Enter. If Ipython is not installed, please refer to the instruction sheet. If Ipython is installed, the Ipython interpreter is loaded by running the Ipython command in the terminal. The versions of Python and Ipython that are installed are shown on the terminal. Some additional helpful information is printed by Ipython. After this, we get a prompt with in bracket 1. Now let us see how we can quit the Ipython interpreter. Press Ctrl D keys. A prompt will appear to confirm if we really want to exit. Type Y for yes and quit Ipython. Note that Y is given in square brackets, so it is default. We could also press enter and it will exit. Else type N for no if you don't want to quit Ipython. Let us type Y. We have quit Ipython interpreter and are back at the terminal prompt. Let us start it again. Type Ipython 3 in the terminal and press enter. Now let us learn how to use the interpreter. Let us start with the simplest operation, addition. Type 1 plus 2 at the Ipython prompt and press enter. We press enter to execute the Python command. Please do so after typing every command. Ipython promptly displays the output as 3. Notice that the output is shown with an out square brackets 1 indication. Let us now try a few more operations such as 5 minus 3, 7 multiplied by 4. Each time we press enter and see the output on the Ipython console window. Let us see how we can navigate to previous commands in Ipython. For example, say we want to execute print open parenthesis 1 plus 2 close parenthesis. Instead of typing the whole command, we can recall the command 1 plus 2 we typed earlier. Use the up arrow key to go back to the command 1 plus 2. Now use the left arrow key to navigate to the beginning of the line. Type the word print open parenthesis close parenthesis on the keyboard. We have changed the command to print 1 plus 2. Now press enter. The interpreter prints the result as 3. Notice that this time the indication out square brackets is not displayed. Now let us execute print 10 multiplied by 2. We use the up arrow key to navigate to the previous command print 1 plus 2. Now replace 1 plus 2 with 10 multiplied by 2 and press enter. As with any programming language, asterisk is used for multiplication operator. Observe the output on the console. Now let us see what is tab completion. Let us consider an example. Supposing we want to use the function print. For this, we just type PRI at the prompt and press the tab key. As you can see on the console, that Ipython has auto-completed the command PRI to print. This feature of Ipython is called tab completion. Let us see some more possibilities of tab completion. Just type P and then press the tab. In this case, we see that Ipython does not complete the command. This is because there are more than one commands beginning with P. Therefore, it just lists out all the possible tab completions of P. Now let us try an exercise. Pause the video, solve the problem and resume the video. Find out the commands starting with AB. List out the commands starting with A. AB auto-completes to ABS, abs. A tab displays a list of all the commands starting with A. Now let us see what the function ABS is used for. We will use the help feature of Ipython to find out this. To see the documentation of a function, type the function name followed by a question mark. The Ipython interpreter will show the documentation for the function. From the displayed information, it says abs accepts a number as input and returns its absolute value. Let us see a few examples. On the console, type ABS minus 19 and then ABS 19. We get 19 as expected in both the cases. Now let us try it for decimal numbers. Let us try ABS minus 10.5. We get 10.5 as the result. Pause the video here, try out the following exercise and resume the video. Look up the documentation of round and see how to use it. Switch to the console for the solution. You can look up the documentation of the function round by typing round ? It says here that the function round rounds a number to a given precision. N digits is the precision value for round function. Notice there are extra square brackets around n digits. This means that n digits is optional and 0 is the default value. Optional parameters are shown in square brackets in Python documentation. Pause the video here, try out the following exercise and resume the video. Check the output of round 2.48, round 2.48, 1, round 2.484, round 2.484, 2. We get round 2.48 is equal to 2.0, round 2.48, 1 is 2.5, round 2.484 is 2.0, round 2.484, 2 is 2.48, which are what we expect. Let us now see how to correct typing errors which we could make while typing on the console. Let us make a typing error deliberately. Type round, open parenthesis, 2.484 and press enter without closing the parenthesis. We get a prompt with dots. This prompt is the continuation prompt of Ipython. It appears when the previous line is incomplete. Now complete the command with close parenthesis and press enter. We get the expected output, that is 2. What if we type an incorrect command and end up with the continuation prompt? In such a case, we can press Ctrl C keys to interrupt the command and get back to the Ipython prompt. Round takes only numbers as input. Type round 1A. Do not close the parenthesis and press enter. We gave alphanumeric value 1A as input. Press Ctrl C to interrupt the execution. Pause the video here, try out the following exercise and resume the video. Type round 2.484 without closing the parenthesis and press enter. Then cancel the command using Ctrl C. Type the command round 2.484, 2. The output on your console should look like this. This brings us to the end of this tutorial. In this tutorial, we have learned to invoke the Ipython interpreter by typing Ipython in the terminal, quit the Ipython interpreter by using Ctrl D, navigate the Ipython session history by using the arrow keys, use tab completion to work faster, see the documentation of functions using question mark, interrupt commands using Ctrl C when we make an error. Here are some self-assessment questions for you to solve. Ipython is a programming language similar to Python. True or false? Which key combination quits Ipython? Ctrl C, Ctrl D, Alt C, Alt D. Which character is used at the end of a command in Ipython to display the documentation? Underscore, question mark, exclamation mark, ampersand. And the answers are false. Ipython is not a new programming language. It is just an enhanced interactive Python interpreter. We use Ctrl D to quit Ipython interpreter. We use question mark at the end of the command to display its documentation. This video summarizes the spoken tutorial project. If you do not have good bandwidth, you may download and watch it. We conduct workshops, give certificates. Please contact us. Do you have questions in this spoken tutorial? Choose the minute and second where you have the question. Explain your question briefly. Someone from the FOSSEE team will answer them. Please visit this site. Do you have any general technical questions in Python? Please visit the FOSSEE forum and post your questions. The FOSSEE team coordinates coding of several solved examples of popular books. We give honorarium and certificates for those who do this. For more details, please visit this site. The Spoken Tutorial project is funded by NME, ICT, MHRD, Government of India. This is Prabhu from IIT Bombay signing off. Thanks for watching.
Hello friends, welcome to the tutorial on using plot command interactively in Ipython. At the end of this tutorial, you will be able to create simple plots of mathematical functions, use the plot window to study plots better. To record this tutorial, I am using Ubuntu Linux 14.04 operating system, Python 3.4.3, and Ipython 5.1.0. Prerequisites to practice this tutorial are: you should know how to run basic Python commands on the Ipython console. If not, for relevant Python tutorials, please visit this website. Let us first open the terminal by pressing Ctrl, Alt and T keys simultaneously. Now type Ipython 3 and press enter. Let us initialize the Pylab package. Type %Pylab and press enter. Let us first understand what is Pylab. Pylab is a convenient Python module which provides plotting functionality and has mathematical and scientific functions. After running %Pylab in the Ipython console, you will see a message using matplotlib backend. This means matplotlib is running. But sometimes you may get an error that says import error, no module named matplotlib. In such cases, you have to install matplotlib and run this command again. Let us come back to the Ipython console. Type Linspace followed by a question mark in Ipython console. Press enter. Please note that the command is linspace and not linespace. The displayed information says that linspace return evenly spaced numbers. which are calculated over the interval start and stop. Press Q to exit the documentation and return to the console. Let's try to generate 100 points from 1 to 100. Type Linspace brackets 1, 100, 100. Here 1 is the start, 100 is the stop, and the next 100 is the number of points. Now press Enter. As you can see, a sequence of numbers from 1 to 100 is displayed. Now let's try to generate 200 points between 0 and 1. We do that by typing Linspace brackets 0, 1, 200 and press Enter. Here is the expected sequence of numbers. In Linspace, the start and stop points can be integers, decimals, or constants. Let us now learn about the Len function. First, we will generate 100 points between -pi and pi. So type Linspace brackets -pi, pi, 100 and press Enter. Here, pi is a constant defined by Pylab. Now let us save this to a variable, say t. Press Enter. If we now type len bracket t and press Enter, we will get the number of points between -pi and pi. Len function gives the number of elements present in a given sequence. Next, let's try and plot a cosine curve between -pi and pi. For this, we use the plot command. Type plot brackets t, cos t and press Enter. As you can see from the cosine plot, cos t get the cosine value at every point corresponding to t. We can also assign the value of cos t to a variable cosine by typing cosine is equal to cos t. Press Enter. And then plot by typing plot t, cosine and press Enter. To clear the plot, we have to use the CLF function. This avoids overlapping of new plots over older plots. In the console, type CLF and press Enter. The previous plot is cleared and a blank plot window is displayed. Now let's try to plot a sine plot. Type plot brackets t, sine t and press Enter. A sine plot is displayed. To study the plot better on the plot window, we can use various options that are available on it. Let us have a look at these options. Moving the mouse pointer along the plot gives us the location of each point on the plot. Notice here at the bottom left of the window there are few buttons. The rightmost among them is for saving the file. Just click on it and type the file name. Let us save the plot by the name sine_curve in PDF format. Click on the drop-down here. As you can see, there are many formats in which to save the file. Formats like PNG, EPS, PDF, and PS are available. We have to specify the format that we prefer at the time of saving. To the left of the Save button is the slider button. Using this button, we can specify the margins of the plot window. To the left of the slider button is the Zoom button. It is used to zoom into the plot. Just specify the region to zoom into. The button to the left of zoom can be used to move the axis of the plot. The next two buttons with left and right arrow icons change the state of the plot. It takes us to the previous or next state of the plot. It acts like the back and forward button in a browser. The last one is home, referring to the initial plot. Pause the video here, try out the following exercise and then resume the video. Plot sin x multiplied by sin x divided by x. Save the plot as sin square by x.pdf. Zoom and find the maxima. Bring it back to initial position. This brings us to the end of this tutorial. In this tutorial, we have learned to start Ipython with Pylab, use the Linspace function to create equally spaced points in a region, find the length of sequences using Len Function, plot mathematical functions using plot, clear drawing area using CLF, usage of buttons in the UI of the plot window such as save, zoom, move axis, back and forward, home. Here are some self-assessment questions for you to solve. Create 100 equally spaced points between -π/2 and π/2. How can we find the length of a sequence? What will the command linspace -π, π, 100 do? And the answers are, we use the command linspace -π/2, π/2, 100 to create 100 equally spaced lines between points -π/2 and π/2. Len sequence underscore name is the function used to find out the length of a sequence. The command linspace -π, π, 100 will return 100 evenly spaced samples from -π to π, including both -π and π. The video at the following link summarizes the spoken tutorial project. If you do not have good bandwidth, you can download and watch it. We conduct workshops using spoken tutorials and give certificates. Please contact us. Do you have questions on this spoken tutorial? Choose the minute and second where you have the question. Explain your question briefly. Someone from the FOSSEE team will answer them. Please visit this website. Do you have any general or technical questions? Please visit the forum given in this link. The FOSSEE team coordinates coding of solved examples of popular books. We have honorarium and certificates for those who do this. For more details, please visit this site. The Spoken Tutorial project is funded by NMEICT MHRD Government of India. This is Usha from IIT Bombay signing off. Thanks for watching. Hello friends, welcome to the tutorial on embellishing a plot. At the end of this tutorial, we will learn to modify the attributes of the plot, color, line style, line width, add a title to the plot with embedded LaTeX, label X and Y axis, add annotations to the plot, set and get the limits of access. To record this tutorial, I am using Ubuntu Linux 14.04 operating system, Python 3.4.3, Ipython 5.1.0. To practice this tutorial, you should know how to run basic Python commands on the Ipython console and use the plots interactively. If not, see the prerequisite Python tutorials on this website. Let us start Ipython 3. Open the terminal, type Ipython 3 and press enter. Let us initialize the Pylab package. Type %Pylab and press enter. We shall first make a simple plot and start modifying it. Type x is equal to Linspace inside the brackets -2, 4, 20 and press enter. Then type plot inside the brackets x, sin x and press enter. We can now see the sine curve in the plot window. The default color and thickness of the line is as decided by Pylab. Let us now change the parameters of this curve. We can pass additional arguments to the plot command to do this. We shall first clear the plot window by typing CLF in the Ipython console. You can now see a blank plot window. Now, plot the same sine curve with an additional color argument. So, we will type plot inside the brackets x, sin x, inside inverted commas r and press enter. Here, the argument r is for red color. On the plot window, the same sine curve is now seen in red color. Do not close the plot window, just minimize it. We can alter the thickness of the line by using the line width argument. This time, we will draw the cosine curve on the plot window. So type plot inside brackets x, cos x, line width is equal to 2. Press enter. A cosine curve with line thickness 2 is produced in the plot window. Let us now try to plot a sine curve in blue color with line width as 3. Here onwards, press the enter key to execute every command that we type on the Ipython console. Let us first clear the plot window by typing CLF. You will again see a blank plot window. Now type plot inside the brackets x, sin x, inside inverted commas b, line width is equal to 3. A combination of color and line width would do the job for us. To get the plot in dotted style, instead of a solid style, put a dot in line style. First, type CLF to clear the plot window. Now type plot inside the brackets x, sin x, inside inverted commas dot. We get the sine curve in dotted style. Let's see the information of plot. Type plot ? and press enter. Pause the video, try this exercise and then resume the video. Plot the curve of x versus cos x in red dashed line and line width 3. Let us switch to the console for the solution. Type CLF to clear the plot window. Now type plot inside the brackets x, cos x, inside inverted commas r, hyphen, line width is equal to 3. We use a combination of line width argument and line style. Now we know how to produce a bare minimum plot with color, style and thickness. Let us look at modifying the plot further. Let us start with a plot for the function minus x square plus 4x minus 5. Now type plot inside the brackets x, minus x multiplied by x plus 4 multiplied by x minus 5, inside inverted commas r, line width is equal to 2. We will see the curve of this equation in the plot window. But the figure does not have any description describing the plot. To add a title to the plot, use the title command. So type title inside the brackets, inside inverted commas, parabolic function minus x square plus 4x minus 5. The title command, as you can see, takes a string as an argument. We can see the title on the plot window. But it is not formatted and does not look clean. It would look even more shabby if there were fractions and complex functions. Let us write the title in LaTeX format for a neater look. For LaTeX format, we put a $sign before and after the string. Type title inside the brackets r, inside inverted commas, parabolic function minus x square plus 4x minus 5 $. Here, r means that the string is to be treated as a raw string. It will ignore all escape codes. As we can see that the polynomial in the title is now formatted. Although we have title, the plot is not complete without labeling the x and y axis. So we will label x and y axis in LaTeX style. Type x label inside the brackets r, inside inverted commas $x, and y label inside brackets r, inside inverted commas $y. The plot is now almost complete. Now we will name the points considering point 2, -1 as local maxima. To name a point, we use the function annotate. Type annotate inside the brackets, inside inverted commas, local maxima, xy is equal to, inside brackets, 2, -1. We can see the local maxima at point 2, -1. The first argument in annotate command is the name of the point. The second argument represents the coordinates of the point. It is a tuple containing two numbers. The first is x coordinate and second is y coordinate. Next, type xlim brackets. Xlim function returns the current x-axis limits. Then type ylim brackets. Ylim function returns the current y-axis limits. Set the limits of x-axis from -4 to 5 by typing xlim inside the brackets -4, 5. Similarly, set the limits of y-axis in a similar manner. Type ylim inside the brackets -15, 2. Pause the video, try this exercise and then resume the video. Make an annotation called root at the point -4, 0. What happens to the first annotation? Switch to the Ipython console for the solution. Type annotate inside the brackets, inside inverted commas, root, xy is equal to -4, 0. Every annotate command makes a new annotation on the figure. This brings us to the end of this tutorial. In this tutorial, we have learned to modify the attributes of a plot like color, line width, line style by passing additional arguments. Add title to the plot using the title command. Incorporate LaTeX style formatting by adding a $sign before and after the string. Label X and Y axis using XLabel and YLabel commands. Add annotations to a plot using annotate command. Get and set the limits of axis using xlim and ylim commands. Here are some self-assessment questions for you to solve. Draw a plot of cosine graph between -2 pi to 2 pi with line thickness 4. Read the documentation and find out, is there a way to modify the alignment of text in the command ylabel? And the answers are, in order to plot a cosine graph between the points -2 pi and 2 pi with line thickness 4, we use the linspace and plot command as x is equal to linspace inside the brackets -2 pi, 2 pi. Plot x, cos x, line width is equal to 4. The answer to the second question is no, we do not have an option to modify the alignment of text in the command ylabel. Do you have questions on this spoken tutorial? Choose the minute and second where you have the question. Explain your question briefly. Someone from the FOSSEE team will answer them. Please visit this site. Do you have any general or technical questions on Python? Please visit the FOSSEE forum and post your question. The FOSSEE team coordinates coding of solved examples of popular books. We give honorarium and certificate for those who do this. For more details, please visit this website. The Spoken Tutorial project is funded by NMEICT MHRD Government of India. This is Usha from IIT Bombay signing off. Thanks for watching.
Hello friends, welcome to the spoken tutorial on saving plots. At the end of this tutorial, you will be able to save plots using savefig function, save plots in different formats. To record this tutorial, I am using Ubuntu Linux 14.04 operating system, Python 3.4.3, Ipython 5.1.0. To practice this tutorial, you should know how to use plot command interactively. If not, see the prerequisite Python tutorials on this website. Let us first open the terminal by pressing Ctrl-Alt-T keys simultaneously. Now type Ipython 3 and press enter. Let us initialize the Pylab package. Type %Pylab and press enter. Let us plot a sine curve from -3π to 3π. First, we will calculate the required points for the plot. To do this, type x is equal to linspace -3 star pi, 3 star pi, 100 in the console. Let us plot a sine curve for the points stored in variable x. Type plot x, sine of x in the console and press enter. Don't close the plot window for the rest of the tutorial. Here you can see that we have made a very basic sine plot. Now let us see how to save the plot. For saving the plot, we will use the savefig function. Savefig function takes one argument, which is the file name. Type savefig sine.png and press enter. This saves the file in the present working directory. The characters after the dot in the file name is the extension. It determines the format in which you want to save the file. To check the current working directory, type pwd in the console and press enter. To save the file in a different directory, type full path of the directory before the file name. Type savefig /home/fossee/sine.png. Note that the above file path is for Linux-based file system. For Windows, give the entire file path as shown here. Here, fossee is the username in Windows, and sine.png file is to be saved on desktop. Here we have used an extension .png. This will ensure that the image is saved as a PNG file. Now let us locate the file sine.png, which we had saved earlier. We have saved the file to /home/fossee. Let us navigate to /home/fossee using the file browser. Open sine.png to see the plotted sine curve. Savefig can save the plot in many formats, such as PDF, portable document format, PS, PostScript, EPS, encapsulated PostScript to be used with LaTeX documents, SVG, scalable vector graphics, .png, portable network graphics. Pause the video here, try out the following exercise and resume the video. Save the sine plot in the EPS format. Let us see the output for this exercise. Type savefig /home/fossee/sine.eps and press enter. Now let us go to /home/fossee and see the new file created. We see the file sine.eps here. Pause the video here, try out the following exercise and resume the video. Save the sine plot in PDF, PS and SVG formats. This brings us to the end of this tutorial. In this tutorial, we have learned to save plots using the savefig function, save the plots in different formats like PDF, PS, PNG, SVG, and EPS. Here are some assignment questions for you to solve. Which command is used to save a plot? Save plot, save fig, save figure, save PLT. Savefig sine.png saves the plot in the root directory / on GNU Linux Unix based systems, C:colon on Windows, will result in an error as full path is not supplied, the current working directory, predefined directory like /documents. And the answers are: to save a plot, we use the savefig function. If we save a file without complete path, it gets saved in the current working directory. Please post your timed questions on this forum. Please post your general queries on Python in this forum. FOSSEE team coordinates the TBC project. Spoken Tutorial project is funded by NME ICT, MHRD, Government of India. For more details, visit this website. This is Prabhu from IIT Bombay, signing off. Thank you.
Hello friends, welcome to the spoken tutorial on multiple plots. At the end of this tutorial, you will be able to draw multiple plots which are overlaid, use the figure command, use the legend command, switch between the plots and perform some operations on each of them, like saving the plots. To record this tutorial, I am using Ubuntu Linux 14.04 operating system, Python 3.4.3, Ipython 5.1.0. To practice this tutorial, you should know how to use plots interactively, embellish a plot, save plots. If not, see the prerequisite Python tutorials on this website. Let us first open the terminal by pressing Ctrl, Alt and P keys simultaneously. Now type Ipython 3 and press Enter. Let us initialize the Pylab package. Type %Pylab and press Enter. Let us create a set of points for our plot by using the command Linspace. Type x is equal to Linspace inside the brackets 0, 50, 10. Now let us draw a simple sine curve using these points. Type plot inside the brackets x, sine x. As we can see, this sine curve is not a smooth curve. What really caused this? This happened because we selected few points, that is 10 for this large interval of 0 to 50. Plot function does not plot the analytical function. It plots the points given by the analytical function. Now, let us use Linspace command to get 500 points between 0 and 50 and draw the sine curve again. Type y is equal to Linspace inside the brackets 0, 50, 500. Plot inside the brackets y, sine y. Now we see a sine curve with a smooth curve. Notice we will also have two plots, one overlaid upon another. In Pylab, by default, all the plots are overlaid. To distinguish between two overlaid plots, we use the legend command. Type legend inside the brackets, square bracket, sin x, sin y. The legend command takes parameter as a list of strings. Then it assigns strings to plots in the order they were created. Now we can see the legends being displayed for the two sine curves on the plot area. In the Ipython terminal, now type CLF to clear the plot window. Pause the video, try this exercise and then resume the video. Draw two plots, first plot being a parabola of the form y is equal to 4x square and the second being a straight line of the form y is equal to 2x plus 3 in the interval -5 to 5. Use legends to indicate what each plot is doing. Switch to the terminal for solution. Type x is equal to Linspace inside the brackets -5, 5, 100. We can obtain the two plots in different colors using the following commands. Plot inside the brackets x, 4 multiplied by inside the brackets x multiplied by x. Plot inside the brackets x, 2 multiplied by x plus 3. Now we will add a legend to identify the plots. Type legend inside the brackets, inside square brackets, r inside inverted commas, $y is equal to 4x square, r inside inverted commas, $y is equal to 2x plus 3, We can see the legend added to the plot. Next, we will learn to switch between the plots and perform operations such as saving the plots, etc. Let us see how to accomplish this. But before we move on, let us clear our screen. Type CLF. Type x is equal to Linspace inside the brackets 0, 50, 500. To accomplish more control over individual plots, we use the figure command. Type figure 1. Plot inside the brackets x, sin x, inside inverted commas b. Figure 2. Plot inside the brackets x, cos x, inside inverted commas g. Now we have two plots, a sine curve and a cosine curve in two different figures. The figure command takes an integer as an argument. This is the serial number of the plot to select corresponding plot. All the plot commands we run hereafter are applied to the selected plot. In this example, figure 1 is the sine plot and figure 2 is the cosine plot. For example, we can save each plot separately. Type title inside the brackets, inside inverted commas, cos x. Save figure inside the brackets, inside inverted commas, cosine.png. Figure 1, title, inside the brackets, inside inverted commas, sine x. Save figure inside the brackets, inside inverted commas, sine.png. The figures will be saved in current working directory. Now, close both the plot windows. Pause the video, try this exercise and then resume the video. Draw a line of the form y is equal to x as one figure and another line of the form y is equal to 2x plus 3. Save each of them. Switch to the terminal for solution. To solve this problem, we will use the figure command to create first plotting area. Type figure 1, x is equal to linspace inside the brackets minus 5, 5, 100. Plot inside the brackets x, x. Now, use the figure command to create second plotting area and plot the figure. Type figure 2. Plot inside the brackets x, 2x plus 3. Save the figure as follows. Type figure 1, save figure inside the brackets, inside inverted commas, plot1.png. Figure 2, save figure inside the brackets, inside inverted commas, plot2.png. This brings us to the end of this tutorial. In this tutorial, we have learned to draw multiple plots which are overlaid, use the figure command, use the legend command, switch between the plots and perform some operations on each of them, like saving the plots. Here are some self-assessment questions for you to solve. What command is used to get individual plots separately? What will be the command to identify sine and cosine curve? And the answers are the command figure can get us the individual plots separately. The legend command, legend inside the brackets, inside square brackets, inside inverted commas sin x, inside inverted commas cos x. Please post your timed queries in this forum. Please post your general queries on Python in this forum. FOSSEE team coordinates the DBC project. Spoken Tutorial is funded by NME ICT MHRD Government of India. For more details, visit this website. This is Usha from IIT Bombay signing off. Thank you. Hello friends, welcome to the spoken tutorial on subplots. At the end of this tutorial, you will be able to create and switch between subplots. To record this tutorial, I am using Ubuntu Linux 14.04 operating system, Python 3.4.3, Ipython 5.1.0. To practice this tutorial, you should know how to run basic Python commands on the Ipython console, use plots interactively, embellish a plot. If not, see the prerequisite Python tutorials on this website. Let us first open the terminal by pressing Ctrl, Alt and T keys simultaneously. Now type Ipython 3 and press Enter. Let us initialize the Pylab package. Type %Pylab and press Enter. To compare two plots, we draw the plots in the same plotting area. Let us now create two plots, a cosine plot and an exponential curve in the same plotting area. Type x is equal to Linspace inside brackets 0, 50, 500 and press Enter. Plot inside the brackets x, cos x. Type y is equal to Linspace inside brackets 0, 5, 100. Plot inside brackets y, y square. Here the two plots have different regular axes, so we cannot draw overlaid plots. In such cases, we can draw subplots. We use subplot command to accomplish this. Type clf subplot inside brackets 2, 1, 1. We can see the first subplot. The subplot command takes 3 arguments. The first argument is the number of rows of subplots that must be created. Here the first argument is 2 to split the plot horizontally. The second argument is the number of columns of subplots that must be created. Here the second argument is 1. So, plot will not split vertically. The last argument specifies the serial number for the subplot. Here, we passed 1 as the argument, which creates the upper subplot. If we execute the subplot command as subplot inside the brackets 2, 1, 2, the lower subplot is created. Here we can see now 2 subplots. Now we can draw plots in each of the subplot area using the plot command. Type subplot inside brackets 2, 1, 1, plot inside brackets x, cos x. Now type subplot inside brackets 2, 1, 2. Plot y, y square. This created 2 plots, one in each of the subplot area. The top subplot holds a cosine curve and the bottom subplot holds a parabola. It is clear from the 2 subplots that both have different regular axes. For the cosine curve, x-axis varies from 0 to 50 and y-axis varies from -1 to 1. For the parabolic curve, x-axis varies from 0 to 5 and the y-axis varies from 0 to 25. Now clear the plot window. Pause the video Try this exercise and then resume the video. Pressure, volume, and temperatures are held by the equation PV is equal to nRT, where nR is a constant. Assume nR is equal to 0.01 joules per Kelvin and T is equal to 200 Kelvin. V can be in the range from 21 cc to 100 cc. Draw two different plots as subplots. Pressure versus volume plot and pressure versus temperature plot. Switch to the terminal for the solution. To start with, we have been given the range of volume from which we can define the variable V. V is equal to Linspace inside brackets 21, 100, 500. We can create first subplot and draw pressure versus volume graph using this V. Subplot 2, 1, 1. Plot V, 2.0 by V. We know that nRT is a constant which is equal to 2. Since nR is equal to 0.01 joules per Kelvin and T is equal to 200 Kelvin. Now we can create the second subplot and draw pressure versus temperature plot as follows. Subplot 2, 1, 2. Plot 200, 2.0 divided by V. We have an error now telling X and Y dimensions don't match. So we will create same number of points for temperature. Type T is equal to Linspace inside brackets 200, 200, 500. Now we have 500 values in T and each with value 200 Kelvin. Plotting this data, we get the required plot. Plot inside brackets T, 2.0 divided by V. We can see two subplots of pressure versus volume and pressure versus temperature respectively. This brings us to the end of this tutorial. In this tutorial, we have learned to create subplots and to switch between them. Here are some self-assessment questions for you to solve. Which of the following is correct? Subplot, bracket, number of rows, number of columns, plot number. Subplot, inside the brackets, number of rows, number of columns. Subplot, inside the brackets, number of columns, number of rows. And the answer is first option. The subplot command takes three arguments, namely the number of rows, number of columns, and the plot number. Please post your timed queries in this forum. Please post your general queries on Python in this forum. The FOSSEE team coordinates the TBC project. Spoken Tutorial is funded by NME ICT, MHRD, Government of India. For more details, visit this website. This is Usha from IIT Bombay signing off. Thank you. Hello friends and welcome to the spoken tutorial on additional features of Ipython. At the end of this tutorial, you will be able to retrieve your Ipython history, view a part of the history, save a part of the history to a file, run a script from within Ipython. To record this tutorial, I am using Ubuntu Linux 14.04 operating system, Python 3.4.3, Ipython 5.1.0. To practice this tutorial, you should know how to use plots interactively and embellish a plot. If not, see the prerequisite Python tutorials on this website. Let us now open the terminal by pressing the Ctrl, Alt and T keys simultaneously. Now type Ipython3 and press Enter. Let us initialize the Pylab package. Type %Pylab and press Enter. To start plotting, type x is equal to Linspace inside the brackets minus 2 pi, comma 2 pi, comma 100 and press Enter. Next, type plot inside the brackets x, comma x sin x and press Enter. We got an error saying x sin is not defined. This is because x sin x is actually x multiplied by sin x. Here the multiplication sign is missing. So let us now type plot inside the brackets x, comma x multiplied by sine of x and press Enter. Next, let us add title and labels for both x and y axis. Type x label inside the brackets, inside inverted commas, inside $sign x and press Enter. Y label inside the brackets, inside inverted commas, inside $sign f of x. Title inside the brackets, inside inverted commas, inside $sign x and x sin x. We can now see the labeled plot. The history of typed commands can be retrieved by the %history command. Type %history and press Enter. %history itself is a command and is displayed as the most recent command. Whatever we executed in the terminal is stored as history. If we want to see what was the fifth command, pass 5 as an argument to the %history command. Type %history space 5 and press Enter. This displays the fifth command which we typed. Now pause the video here and try out the following exercise and resume the video. Find out how to list the recent commands between 5 and 10. Switch back to the terminal. Let us look at the solution. Type CLF and press Enter. Type %history ? Read through the information of %history command. We can see %history -n 4-6 displays the commands from 4 to 6. Here -n is an optional argument which prints the line numbers. Type Q to quit the documentation. Now type %history space 5-10 and press Enter. To save the history, we use the %save command. Before we do that, let us first look at the history and identify which lines of code we require. Type %history and press enter. The second command is Linspace, but the third command is a command that gave us an error. Hence, we do not need it. The commands from 4th to 7th are required. So, we need the second command and then the 4th to 7th commands of our program. Let us save it in the present working directory. Hence, the syntax will be %save space plot underscore script.py space 2 space 4-7 and press enter. The first argument in %save command is the name of the file in which the commands are saved. The second argument gives the numbers of the commands that are being saved separated by spaces. Let us now open the file plot underscore script.py and see the contents. Let us learn how to run the file as a Python script. We use the command %run to do this. Type %script.py and press enter. Here, -i parameter runs the code written in a text editor. The code is run within the current Ipython session. It uses the variables defined interactively in the Ipython session. The script runs, but we do not see the plot. This is because when we are running a script, we are not in the interactive mode. To view the plot, type show on the terminal and press enter. Pause the video here and try out the following exercise and resume. Use %history and %save to create a script that has the function show in it. Run the script to produce the plot and display the same. Let us look at the solution. We first look at the history using the %history -n command. Type %history space -n and press enter. Let us clear the plot window. Type clf and press enter. Now, let us save the script using the command %save. We need the lines 2, then 4 to 7 and 16. Type %save space show underscore included dot py space 2 space 4-7 space 16 and press enter. To run the script, type %run space -i space show underscore included dot py and press enter. We get the desired plot. Go to the previous command, modify it by removing -i in the command to %run space show included dot py and press enter. We see that it raises a name error saying that the name Linspace is not defined. This happens because we did not run the script interactively. This brings us to the end of this tutorial. In this tutorial, we have learned to retrieve the history using %history command, view only a part of history by passing argument to %history command, save the required lines of code in the required order using %save command, use %run space -i command to run a saved script. Here are some self-assessment questions. How do you save the command lines 2, 3, 4, 5, 7, 9, 10 and 11? Percentage save file name 2-5 7 9-11. Percentage save file name 2-11. Percentage save file name percentage save 2-5 7 9 10 and 11. Which is the command to run the script? Percentage execute the script name, percentage run -i script name, percentage run script name, percentage execute -i script name. And the solutions are: to save the commands 2, 3, 4, 5, 7, 9, 10 and 11, we issue the command percentage save file name 2-5 space 7 space 9-11. To run the script, we use percentage run space -i space the script name. Please post your timed queries in this forum. Please post your general queries on Python in this forum. The FOSSEE team coordinates the TBC project. Spoken Tutorial project is funded by NME-ICT MHRD Government of India. For more details, please visit this website. This is Usha from IIT Bombay signing off.
Hello friends, and welcome to the spoken tutorial on loading data from files. In this tutorial, you will learn to read data from files which contain data in single column format or multiple columns separated by spaces or other delimiters. To record this tutorial, I am using Ubuntu Linux 14.04 operating system, Python 3.4.3, Ipython 5.1.0. You should know how to run basic Python commands on the Ipython console. If not, for relevant Python tutorials, please visit this website. Let us first open the terminal by pressing Ctrl, Alt and T keys simultaneously. Now type Ipython 3 and press Enter. Let us initialize the Pylab package. Type %pylab and press enter. Let us begin with reading the file primes.txt. This file contains a list of prime numbers listed in a column. Type cat space primes.txt. We can use cat command to fetch data from the file and display it on the terminal. Press enter. We see the prime numbers are displayed on the terminal. Now we can use the loadtxt command to store this list into the variable primes. So type primes equal to loadtxt within parenthesis within double quotes primes.txt and press enter. Please make sure that you provide the correct path to the file primes.txt. The file in our case is present in the home folder. Primes is now a sequence of prime numbers that was listed in the file primes.txt. Now let us display the contents in the variable primes. So type print within parenthesis primes and press enter. We see the sequence printed. We observe that all numbers end with a period. This is because all these numbers are floats. Now type cat space pendulum.txt and press enter. This file contains two columns. The first column contains the length of the pendulum. The second column contains the corresponding time period. Let us now read the data from the file into the variable pend using the loadtxt command. So type pend equal to loadtxt within parenthesis within double quotes pendulum.txt and press enter. Please note that the loadtxt needs both the columns of the file to have equal number of rows. Now print the variable pend to see what it contains. Type print within parenthesis pend and press enter. Notice that the variable has two sequences containing two columns of the data file. Let us use an additional argument of the loadtxt command to read the data into two separate sequences. So type L, T equal to loadtxt within parenthesis within double quotes pendulum.txt after double quotes comma unpack equal to true and press enter. Now print the variables L and T to see what they contain. Type print within parenthesis L and press enter. Print within parenthesis T and press enter. Notice that L and T now contain the first and the second columns of the data from the pendulum.txt respectively. Unpack equal to true has made the two columns into two separate and simple sequences. Pause the video over here and try out the following exercise and resume the video. Read the data from the file pendulum_semicolon.txt. This file contains data in two columns. These columns are separated by semicolons. Use the Ipython help to see how to do this. Let us look at the solution. Switch to the terminal. First, we will see the content of the file. So type cat space pendulum_semicolon semicolon.txt and press enter. We see the two columns separated by a semicolon. Now type L, T equal to Loadtxt within parenthesis within double quotes pendulum underscore semicolon dot txt. After double quotes, comma, unpack equal to true, comma, delimiter equal to within double quotes semicolon and press enter. Now print within parenthesis L and press enter. Print within parenthesis T and press enter. This will display the contents inside the two variables L and T. This brings us to the end of the tutorial. In this tutorial, we have learned to read the data from files using the loadtxt command. The data can be in a single column format or multiple column format, separated by spaces or other delimiters. Here are some self-assessment questions for you to solve. Loadtxt can read data only from a file with one column. Is it true or false? Second, given a file data.txt with 3 columns of data separated by spaces, read it into 3 separate simple sequences. Given a file data.txt with 3 columns of data separated by a colon, read it into 3 separate simple sequences. Now let us look at the answers. The answer to the first question is false. The loadtxt command can read data from files having single columns as well as multiple columns. The answer to the second question is, to separate data into 3 columns, we use loadtxt command as follows. X is equal to loadtxt within parenthesis within double quotes data.txt after double quotes comma unpack equal to true. The answer to the third question is, we read into 3 separate sequences by using an additional argument of delimiter in the loadtxt command. So x equal to loadtxt within parenthesis within double quotes data.txt unpack equal to true, comma, delimiter equal to within double quotes colon. Do you have any questions on this spoken tutorial? Please visit this site. Do you have any general or technical questions? Please visit the forum given in the link. The FOSSEE team coordinates coding of solved examples of popular books. We give honorarium and certificates for those who do this. For more details, please visit this site. The Spoken Tutorial project is funded by NMEICT MHRD, Government of India. This is Prathamesh Sarunke from IIT Bombay signing off. Thanks for watching. Hello friends, welcome to the tutorial on plotting data. In this tutorial, we will learn about define a list of numbers, perform element-wise squaring of the list, plot data points, and plot error bars. To record this tutorial, I am using Ubuntu Linux 14.04 operating system, Python 3.4.3, Ipython 5.1.0. To practice this tutorial, you should know how to run basic Python commands on the Ipython console, use plots interactively, embellish a plot. If not, see the relevant Python tutorials on this website. Let us first open the terminal by pressing Ctrl Alt T keys simultaneously. Now type Ipython 3 and press Enter. Let us initialize the Pylab package. Type %pylab and press Enter. Let us see an example for plotting the data related to a simple pendulum. For a simple pendulum, L is directly proportional to the square of time t. We will be plotting L and t square values. Let us use the data shown here for plotting. First, let us initiate L and t values. We initiate them as sequence of values. This is also called as list. Type L equal to within square brackets values and press Enter. T equal to within square brackets the values and press Enter. Now we will obtain square of t by using function square. Type t square equal to square within parenthesis t and press Enter. Now type t square and press Enter. We see the values of array t square. Now to plot L versus t square, we simply type plot within parenthesis L, t square, within single quotes dot and press Enter. We see the required plot. You can also specify O for filled circles. For this, let us clear the plot first. Type CLF parenthesis Enter. So the plot is clear now. Now type plot within parenthesis L, t square, within single quotes O and press Enter. We see the plot with filled circles. Pause the video, try this exercise and then resume the video. Plot the given experimental data with large dots. The data is on your screen. Use the error data given here for plotting. We shall again initialize the sequence values in the same manner as we did for L and T. So type delta underscore L equal to within square bracket the values and press Enter. Delta underscore T within square bracket the values and press Enter. Now to plot L versus t square with an error bar, we use the function error bar. So type error bar within parenthesis L, t square, Xerr equal to delta underscore L, Yerr equal to delta underscore t, fmt
equal to within single quotes BO and press enter. We see the plot L versus T square with an error bar. You can explore other options of error bar using the documentation of error bar. That is error bar ? Pause the video, try this exercise, and then resume the video. Plot the given experimental data with small dots. Also include the error in your plot. Use the data given here for plotting. This brings us to the end of this tutorial. In this tutorial, we have learned to declare a list of numbers using the function array. Perform element-wise squaring using the square function. Use various options available for plotting like dots, lines, etc. Plot experimental data such that we can also represent error by using the error bar function. Here are some self-assessment questions for you to solve. Square the following sequence distance underscore values equal to within square brackets 2.1, 4.6, 8.72, 9.03. Plot L versus T in red pluses. And the answers. To square a sequence of values, we use the function square. So square within parenthesis distance underscore values. Answer to the second question, we pass an additional argument stating the desired parameter. So plot within parenthesis L, T, within single quotes R plus for red pluses. Please post your timed queries in this forum. Please post your general queries on Python in this forum. FOSSEE team coordinates the TBC project. Spoken Tutorial is funded by NMEICT MHRD Government of India. For more details, please visit this website. This is Prathamesh Saunke from IIT Bombay signing off. Thank you. Hello friends, welcome to the tutorial on other types of plots. At the end of this tutorial, you will be able to create Scatterplot, create log-log plots. To record this tutorial, I am using Ubuntu Linux 14.04 operating system, Python 3.4.3 and Ipython 5.1.0. To practice this tutorial, you should know how to run basic Python commands on the Ipython console, load data from files and plot data. If not, see the relevant Python tutorials on this website. Let us first open the terminal by pressing Ctrl, Alt and T keys simultaneously. Now type Ipython 3 and press enter. Let us initialize the Pylab package. Type %pylab and press enter. In a scatter plot, the data is displayed as a collection of points. Each point determines its position on the x and y axis. Plot a scatter plot showing the percentage profit of a company A from the year 2000 to 2010. The data for the same is available in the file company-a-data.txt. Company-a-data.txt file is available in the code file link of this tutorial. Please download and use it. Let us see the content of the file company-a-data.txt. So type cat company-a-data.txt and press enter. The data file has two columns with a set of values in each column. The first column represents the years and the second column represents the profit percentage. To produce the scatter plot, we first need to load the data from the file using loadtxt command. So type year, profit equal to loadtxt within parenthesis within single quote company-a-data.txt after single quote unpack equal to true and press enter. Unpack equal to true returns the transposed array of data. Scatter function is used to generate the scatter graph. Syntax scatter within parenthesis x, y. X is a sequence of data and y a sequence of data having the same length of x. Let us use the scatter function to plot scatter graph for data stored in year and profit. So type scatter within parenthesis year, profit and press enter. Notice that we pass two arguments to scatter function. The first one being the values in x coordinate, that is years. Second, the values in y coordinate, the profit percentages. Pause the video here, try out the following exercise and resume the video. Read the documentation of scatter. Plot a scatter plot of same data in company-a-data.txt with the red diamond markers. Solution to the exercise. Clear the plot window by typing CLF parenthesis and press enter. Now type scatter within parenthesis year, profit, color equal to within single quote R, marker equal to within single quote D and press enter. Thus we got our scatter plot. Now let us see another kind of plot. A log-log plot is a two-dimensional graph of numerical data. It uses logarithmic scales on both axes. Graph appears as straight line due to non-linear scaling. Syntax log within parenthesis x, y. X is a sequence of data. Y a sequence of data having the same length of x. Plot a log-log chart of y equal to 5 times x cube for x from 1 to 20. Before we actually plot, let us calculate the points needed for that. Type x equal to Linspace within parenthesis 1, 20, 100 and press enter. then y equal to 5 into x raised to 3 and press enter. Clear the plot window by typing CLF parenthesis and press enter. Type log within parenthesis x comma y and press enter. We see the required plot. This brings us to the end of this tutorial. In this tutorial, we learned to plot a scatter plot using scatter function, plot a log-log graph using log-log function. Here are some self-assessment questions for you to solve. Scatter within parenthesis x comma y color equal to within single quote blue comma marker equal to within single quotes D and plot within parenthesis x comma y color equal to within single quotes B comma marker equal to within single quotes D does exactly the same, true or false? And the answer, false. Both functions do not produce the same kind of plot. Please post your general queries on Python in this forum. FOSSEE team coordinates the TBC project. Spoken Tutorial project is funded by NMEICT MHRD Government of India. For more details, visit this website. This is Prathamesh Saunke from IIT Bombay, signing off. Thank you.
Hello friends, welcome to the tutorial on plotting charts. At the end of this tutorial, you will be able to create pie charts, create bar charts, and find more information on matplotlib. To record this tutorial, I am using Ubuntu Linux 14.04 operating system, Python 3.4.3, and Ipython 5.1.0. To practice this tutorial, you should know how to run basic Python commands on the Ipython console, load data from files and plot data. If not, see the relevant Python tutorials on this website. Let us first open the terminal by pressing Ctrl-Alt-T keys simultaneously. Now type Ipython3 and press enter. Let us initialize the Pylab package. Type %Pylab and press enter. A pie chart is a circular chart divided into sectors to illustrate numerical proportion. The syntax is as follows: pie inside parenthesis, values, comma, labels equal to labels, where values are the data to be plotted and labels the label for each wedge in the pie chart. Plot a pie chart representing the profit percentage of company A. Use the data from file companydata.txt available in the code file link of this tutorial. The data file has two columns with a set of values in each column. The first column represents years,
The second column represents the profit percentages.
To produce a scatter plot, we first need to load the data from the file using Loadtxt command. Let us clear the terminal. Type here, profit equal to Loadtxt inside parenthesis, inside single quotes. Add the path of the file companyadata.txt, unpack equal to true and press enter. Unpack equal to true returns the transposed array of data. Type CLF open and close parenthesis to clear the plot window if any plots executed previously. Type pi profit, labels equal to year and press enter. Notice that we pass two arguments to the function pi. First one being the values, which is profit in our case. The next one being the set of labels to be used in the pie chart, which is year in our case. Pause the video here, try out the following exercise and resume the video. Plot a pie chart with the same data with the following colors for each wedges: white, red, black, magenta, yellow, blue, green, cyan, yellow, magenta, and blue. Hint: in your Ipython interpreter, try typing pi ? Solution to exercise 2. Clear the plot window by typing CLF open and close parenthesis and press enter. Type pi inside parenthesis profit, labels equal to year, colors equal to inside parenthesis the color codes, and press enter. This will display a pie chart with each wedge having the color as specified in the parameters. A bar chart is a chart with rectangular bars with lengths proportional to the values that they represent. The syntax for bar chart is bar inside parenthesis x, y, where x a sequence of data and y a sequence of data the same length of x. Plot a bar chart representing the profit percentage of company A. Use the data from file companyadata.txt. Solution to exercise 3. Clear the plot window by typing CLF open and close parenthesis. Type bar open and close parenthesis year, profit and press enter. This will display a bar chart representing the profit percentage of company A. Plot a bar chart as shown in the image. Hint: bar chart is not filled and which is hatched with 45-degree slanting lines. The data for the chart may be obtained from the file companyadata.txt. Hint: in your Ipython interpreter, try typing bar ? Solution to exercise 4. Clear the plot window by typing CLF open and close parenthesis. Type bar open and close parenthesis year, profit, fill equal to false, hatch equal to inside single quotes slanting line, and press enter. This will display a bar chart which is not filled and which is hatched with 45-degree slanting lines. Help about matplotlib can be obtained from matplotlib.sourceforge.net/contents.html. More plots can be seen at the following links. This brings us to the end of this tutorial. In this tutorial, we learned to plot a pie chart using pi function, plot a bar chart using bar function, and access the Matplotlib online help. Here are some self-assessment questions for you to solve. What statement can be issued to generate a bar chart with vertical line hatching? And the answer is bar x, y, fill is equal to false, comma, hatch equal to a vertical line is the correct option to generate a bar chart with vertical line hatching. Please post your timed queries in this forum. Please post your general queries on Python in this forum. FOSSEE team coordinates the TBC project. Spoken Tutorial project is funded by NMEICT MHRD Government of India. For more details, visit this website. This is Truptikini from FOSSEE, IIT Bombay, signing off. Thank you.
Thank you.